So what we did was we developed this technology that allows to take the 2 billion parameter model, select a set of capabilities, benchmarks, or like, hey, this is the one query I care about, and then shrink it down to size.
Hello, AI Tinkerers, and welcome to another edition of One Shot. This is where we meet the leaders and innovators in the community who are really pushing the frontiers in some way. And we go under the hood with them, really kick the tires a bit and show how to use their technology and a little bit about how they might have built it so that we can enable a fellow tinkerer in their projects. Today, I'm super excited. We're here with Vic from Moondream. Vic, thanks for coming.
Hey, Joe, super excited to be here.
Tell everyone what Moondream is.
Yeah, we're focused on building computer vision that works for developers wherever they want to run it, whether it's in the cloud, on their phones, on their laptops, or even on edge devices like your Raspberry Pis and Arduinos and whatnot.
Talk about the edge device piece, because running a vision model is you've got a couple flavors, and one is like really small. They're both small.
Mm-hmm.
Tell us more.
Yeah. Traditional computer vision algorithms tended to be really small and focused on edge deployment. But the problem with them was they were narrow. So you had to deploy a model for object detection, another one for segmentation, etc. And they were also hard for developers to get into without having a background in machine learning, because usually your first step in training an object detection model is to get a bunch of training data and figure out how to train it. Vision language models came along and made the developer experience a lot easier. Because now, rather than having to train models, you can just prompt them and they, for the most part, work.
It's the same thing that happened in text, where you used to train classifiers and that would give you a very narrow classification for one problem.
Exactly.
Now you can prompt general purpose for anything. Vision's followed that same path. In fact, the Coursera course that I took 5 or 6 years ago was the first ML model you did do was to train a vision as a classifier dogs versus cats, and you gathered the data by basically running a Google image search.
Yep.
And but it was a good instruction on sort of like old school ML pipelines, cross validation, all this. But I would never do that myself in an application, because I can use Moondream and get one shot incredible results without doing any work. So that's kind of okay. So that's Moondream. When did you start working on it?
Almost exactly a year ago.
Okay. I thought more than that, because I remember meeting you at a Tinkerers.
Our first release was December.
Okay.
December 29th, if I'm not mistaken, last year. So I might have been working on it before that at the first time we met, but we hadn't shipped yet.
Because it was back when we did our very first hackathon in 2023. It was in the summer, I think. I remember someone mentioning you as tinkering on this like thing, and you're still at Amazon, I think.
Yeah. I don't know if I was, the years are a little messed up in my brain. I don't think I was working on this summer 2023. I was doing other stuff. Messing around with language models and stuff.
Interesting. Yeah. Okay, cool. Well, it's super cool. It's really fun. Do you want to let's show people what it does?
Yeah.
Like, let's go and dive in.
So this is our Moondream playground. We just have this online for people to play around with the model.
And you're completely like open weights. Like, I could go download and deploy this on my own device.
Great. You can everything we're showing you can download.
And you're running, you've got a playground. Is this for just demo purposes, or are you running
it's just for demos?
You're not running an inference service for people to actually like build apps on top of, or are you?
We do that as well, not to make money off of it, just to make that, like, when you're getting started, you don't want to figure out how to run inference locally. So just for that purpose.
And if you were like, I want to scale to gajillions, you could go to our providers who have deployed Moondream. Replicate, I know, I've used it there.
There's Replicate, there's Fal, there's a couple of others.
Okay.
But yeah, they're available.
Yeah.
We're also happy to talk to you.
Nice. If you've got it, sure, an industrial use case, you could do that. Could show us, like, let's.
So we have a couple of different capabilities in Moondream. I'm going to show off visual question answering first, call it VQA. You can just ask general purpose questions about images. One of the things that's really important for developers is structured outputs. So you can do what is the girl's hair color, eye color, and what is she saying? Output. I have not tried this prompt, so we'll see.
Oh, cool. Oh, nice. Fast.
Yeah.
Message Moondream spotted. Yeah, I got it. Purple, blue. That's really cool.
We've got a couple of other capabilities too. Like if you look at pointing, for example.
Yeah.
In a lot of cases, you want to localize where objects are in the image,
Oh, you're pointing at text and it spotted it in 2 places. That's cool.
And then I shows up here.
Okay.
We've got general purpose captioning, object detection, but yeah, that's.
I don't know if you noticed, but I wore this today because I thought it would be challenging. It's camouflage and you can't see it. So
we'll have to test the model out.
Yeah. Okay. So you've got a few different modes. Like, can you show us like, okay, so there's VQA, which is visual understanding, captioning, which we know what that means, I guess. Object detection, you showed us pointing at objects. Object detection is
object detection is going to be similar. So if you do text.
And you're returning like X, Y, width, height or something, and an array? An array of them.
Mm-hmm.
How many, like, at what point does this break? Like, if I take a picture of like Times Square, New York, with like tons of images and pictures, and I say, give me all the bounding boxes of all the text that you see.
One of the flaws in our object detection right now is if there are objects that are tightly grouped together and that sort of thing, it just draws one box around the whole group.
Oh, okay.
It kind of works, but usually not what people are looking for.
Got it. But you could write a little bit of logic to like iteratively get.
Yep. You probably want to crop it into smaller bits so that the model can.
Okay. That makes sense. It's very fast. I mean, that's obviously, I guess, a function of being a small model. Are we seeing the 2 billion model or the 0.5?
This is the 2 billion parameter version of the model. With our latest release, by the way, I just ran this benchmark a couple of minutes ago. We've optimized inference code.
Mm-hmm.
So with this is running on a 3090. Each image takes about 150 milliseconds to process. And then once you start generating tokens, you get 128 tokens per second or so. It's running FP16. So
show us
fast.
On the visual, the VQA is pretty new, right? Because I mean, they go to captioning and say like how old do you think the girl is, and what is she wearing?
Yeah, captioning doesn't give you a lot of controls. It just like generates.
It's stuff. Literally no prompt. Okay.
Yeah, a lot of people were using it for this. They were like, "What prompt should I use?" So we just put it in so that people don't have to worry about it.
You can pass a prompt to it though, right? In the API.
The API that you pass a prompt to, we call query. It's VQA here.
The VQA. So, okay. So you basically segmented out like a simple captioning and no parameter basically.
Right. Yeah, but I can type the prompt in here. It was like, how old is the girl and what else?
What is the purpose of those clothes? Like, what is that, a uniform? Is that work? What is that? The clothes look interesting. What's the history behind that? I'm trying to get at something that involves a little bit more knowledge than just observation. What style of clothes is that, maybe? Yeah, there we go. Anime characters, sailor style shirt. Okay, so great. All right. Interesting. Cool. Okay, and then you currently don't combine the bounding box with the VQA.
No. What you can do is you have to phase that. Our image encoding can be done upfront, and it's pretty cheap to do. So once you encoded the image, that takes about 150 milliseconds or so. You can run multiple prompts on it for fairly cheap.
Cool. Have you? Can you just go even deeper under the hood in terms of the ML behind this? Like, it's to sort of ferret out, like, how are you training in order to get like it to adhere to JSON output when you ask for XML, or to answer questions, and what kind of data sets are you using to get there? And then you've added like bounding boxes, and that sort of breaks my brain in terms of like, well, how do you do both in one model? And then they've got gaze detection, which you haven't showed us, but we could show that in a minute. How do all those things work together? It's one model. Like, tell us, how does that happen?
Yeah. One of the things you mentioned was historically, like most of the early vision language models were mostly just focused on captioning, blip, etc.
That's right.
The reason for that was the data that's available for people to train on is image and alt text pairs. And so if you want to do like a big internet pre-train and whatnot, that's what you're doing.
Sure.
To get these other outputs, you have to transform those captions, the alt text, which very noisy, by the way, into other formats that your users are interested in. So for example, if you get a caption that says 3 men standing on a hill, you can use another language model, a text-only language model, to transform that into question-answer pairs, like how many people are on this hill.
So you're using a pipeline pre-training to generate the things that you'd like it to be able to answer, that the captions are the answers for, and that becomes the data set. But how do you get data for bounding box?
There's a lot of publicly available data sets for that one.
Okay.
So old field of computer science.
And you're jamming in sort of captioning, question and answer, bounding box, gaze detection, all into one giant kind of dating set that's your training once to one model called Moondream.
One of the interesting things I observed was in the text space, people have largely consolidated on LLMs as interface, like whether you're doing classification, tagging, entity extraction, you just use an LLM. That consolidation hasn't happened yet in the vision space.
No.
Right now, you use YOLO World if you want to do object detection, you use SAM if you want to do segmentation. We're seeing a lot of benefits from like this cross training. So when we did case detection, for example, it made the model better at answering questions like, which direction is she facing? Got it wrong. Well, from her perspective, it's left.
That's a good test case. You can never be wrong.
But yeah, we have an internal benchmark for this. Historically, it was a struggle for this exact reason. Like in a lot of cases, the captions say looking to their left, looking to our left. The model doesn't really pick up on that, but case detection improved that.
How do you, and I don't know if you've seen Quinn's visual reasoning stuff, which is a large model, totally different in that sense, but compare the what's going on there to the VQA. And for those who haven't seen the Quinn, maybe can you explain what I'm talking about?
If I'm thinking of the right release, Quinn did an O1 style reasoning model.
Yes.
QWQ.
Yes.
And then they later released a vision version of that where they attached vision encoder.
And so for those who haven't tried it, it's fascinating because and they're very transparent about here's the reasoning. So if you give a picture like this and you're like, where is she? It'll be like, well, okay, this is a Japanese anime, so it's probably in Japan. Let's look at the background. This could, although it could be, and it's sort of like, it talks out loud like a person exposing their inner thoughts. That's very interesting. I'm curious, how does your VQA differ from that and what's going on?
Quinn's model is very focused on reasoning beyond just images. Yeah. So we're solely focused on solving the problem of visual perception for developers. If your task is like, hey, I want users to be able to take a picture of a differential equation and then solve it, Moondream can at best give you a LaTeX representation or a description of what the problem is. Yeah. We're not focused on solving it. Yeah. We have been working, this hasn't shipped yet. We have been working on an implementation of chain of thought over here that's specifically focused on solving visual reasoning problems. Reading gauges has been like my nemesis for the last couple of months because of dataset bias. Like every gauge on the internet is just set to 0. So we've come up with this sort of visually grounded chain of thought where it's like, hey, I see this centigrade label here, the needles here, etc. And then we use that to. So
it sounds like you're very focused on like this, including this feature, is to sharpen the tool that you're building, and the tool is for very specifically. You want to nail a bunch of vision use cases, which could be used in robotics and automation and just simple classification and queries and all that, right? Okay. And that's why that's very clear now. And let's talk about like positioning in the market, like the small, like the 500 million parameter is very small. Yeah. I'm not going to ask about benchmarks quite yet, but like talk about where it can run. Like, can I run it on a Raspberry Pi?
Yeah. Let me talk about why we did it and how we did it first before I get to the stats. In vision, unlike text, it's still important to run on edge. A lot of people don't want to upload their data to the cloud, or they have a lot of data, so it's really inefficient to send to the cloud. Yeah. And so 2 billion is like a decent size for a home desktop with a GPU and whatnot, but for edge, it doesn't really work. So what we did was we developed this technology that allows to take the 2 billion parameter model, select a set of capabilities, benchmarks, or like, hey, this is the one query I care about, and then shrink it down to size. We picked 0.5B as kind of an arbitrary target and picked a couple of benchmarks that we wanted to preserve performance on. And it was more of a proof of concept that like, hey, we can prune it. We wanted to prove to ourselves that our thesis works.
What is the optimal when I'm uploading a picture to it, to the 0.5 model? And, I mean, if I give you a 10 megapixel image, it's not going to give me any more accuracy, right? What's the optimal?
The size of the image?
Yeah. If I'm using Moondream, should I resize my images before I send them to you?
Yeah. Our SDK does that automatically.
But if I wanted to make it faster, I might not want to send them over the wire.
We do dynamic cropping based on the aspect ratio. So the real question is like, what is the maximum pixel area that you can send in?
Dynamic cropping meaning you're cropping to the interesting part of the image?
No, like if your image is wide, then we allow you to be more wide. there's no maximum resolution, but if it's also tall, then we reduce the width. So like 1.7 million pixels is our max supported resolution for the 2 billion parameter model.
So you'd recommend we crop down to that number optimally?
It depends upon your task. If you're doing something like OCR and it's like a tiny part of the image, the model needs that high resolution. If it's stuff like, is there a person in this room? Like the lowest resolution we support is 378 by 378. So just
you can go way lower for that because you're using
the model runs way faster that way.
Okay. Oh, it does. So it's interesting as an application developer to understand this and maybe even benchmark and test it in your own apps.
Yeah. Different tasks require a different amount of resolution and processing, and there's a knob that you can dial.
And you might have to chunk things up, obviously, if you've got like gigapixel, handwriting samples.
Fine Waldo or something.
Yeah.
Coming back to 0.5B, again, arbitrary size that we picked, we think most customers will want a custom version of the model for their hardware and their task.
Yeah.
But yeah, it runs great on a Raspberry Pi, decent.
How much memory?
Speed. When quantized to int4, it uses 816 megabytes.
There you go. Wow. Okay.
And we've not quantized the full model. There's more room.
All right. So stepping back out for a minute, like, okay, you've seen Coqui, which is text to speech with 80 million parameters. We were playing with it earlier. The Coqui, Moondream, what would you use for like a light LLM for just, would you use Tiny Llama or something?
I think LLaMA 1B has been performing great for us, 1 or 3B.
1B? Okay.
Yeah.
So those three things on a Raspberry Pi, can they run on it? I think Tiny Llama can, right?
They can run. It's really a question of like processing speed.
Or spend another $100. Yeah. Okay. And then or maybe have two of them. Air gapped. You've got HAL 2000.
Pretty much.
I mean, it's incredible that we're here already. It's barely 2025 and you can actually build this in a weekend and have HAL 2000, and actually start to do function calling in your house and stuff and not have to share. Like I've been, as you know, for months and months talking to you about like, how do I do image recognition? So maybe we'll talk about that next. The thing I want to build is an air-gapped home automation security system that I feel comfortable like using my cameras. I have indoor cameras for security. I'm not streaming those to the cloud at all because we walk around naked, right? I mean,
many people do.
And I'm not worried about, one of the big providers violating their security agreement. I'm worried about leaks. And things. It's just there's use cases I think where and work about and performance too. I don't want to bog my network down streaming all this to the cloud all day long. It's just it's insane. I really, really love the idea of a air gapped, security system that built on these components where I could start to do interesting things. And but let's double click into the one aspect I just brought up. Do you remember? It was if I'm doing image recognition, if I'm doing Moondream locally, okay, sorry, we're going to cut this piece out. So I want to look too stupid, but basically, we talk about gaze detection, or we talk about, no, I don't want to bring that in. What we're just
There's some home security.
Oh yeah, the image recognition. So, all right. So you've got HAL 2000, you want to do automation and security. I come home, it recognizes that it's me as opposed to like my son or my wife, and it knows, whatever, to play the jazz music. I don't know.
Yeah.
Okay. Which I can do. I could call Sonos. I can do this. I can have my camera send and do this inference. Easy. But I need to know it's me, not a delivery person, not the mailman, not, a friend.
Yeah.
So, Flux are these things I've fine-tuned. They do a fantastic job in that direction of taking samples, or relatively few samples, and generating what would fool my mom, synthetic images. Can I do the reverse? Can I fine-tune Moondream in a way that will uniquely recognize me and not falsely someone else?
Yeah.
And how much data would I need if I was to do that?
This is one of those cases the model hasn't seen enough of you are bad. So it doesn't work out of the box, but
can I fine-tune?
We provide fine-tuning scripts.
Yeah.
You can run it for free on a Google Colab instance. For this specific case, like, hey, I needed this to differentiate whether it's me or some random person or someone else in my family.
Is that a use case of fine-tuning in this case?
Yes, you probably need like, I think you'd start with 10 images initially, and then you can expand that to 100 or so with like random cropping, flipping it and whatnot.
Yeah.
We've seen it work great for people. You can run it in a Google Colab notebook.
Yeah.
It fits in the free tier.
So if I had another guy who was basically my height and weight and hair color and stuff.
He'll play jazz when he entered your house.
Kind of not high-res image, right? And it's kind of small. You think it would actually differentiate between us? If enough fine tuning. That's a use case that's
again,
possible.
like the harder the inference gets, the more data you're going to need.
Sure. But that's a valid use case of fine tuning. That's fantastic.
Yeah.
That's
Having said
awesome.
that, I would not recommend people use this for home security. Don't do an unlock my door if it sees me, because I'm going to show up with a picture.
Well, what I'll probably use is the Kokoro ASMR voice.
Yeah.
To be like, "Hi, I don't recognize you. Who are you?" And then have the person say their name, and then I'll use that to train eventually.
Yep.
What kind of music do you like? It's fascinating to just imagine these use cases. Well, what are some of the practical use cases that you're seeing people? You're out there on Twitter. You're a master shit poster, by the way. Congratulations.
It's a disease.
You're really good at it. No, I mean that in a complimentary sense, but obviously you've had some good posts. Moondream's out there. People are playing with it. They're pulling it down. They're tinkering. What are you seeing them build on the tinkering kind of side? And then also, like, when they bring it into their company and they deploy, what are some of the use cases that you're getting excited about?
One of the things that's amazing about running an open source project is you put something out there and people educate you on how it can be used. So some of the things that people are using it for has blown my mind. The best example I have is there's a rancher somewhere in Texas who has cows that sometimes get out, and he wanted to fly a drone over his property and find, like, hey, are there cows where they shouldn't be?
Wow. So he flies the drone autonomously to just alert?
I believe so. I didn't dig into this a lot. This was way back. But in terms of general, where we're seeing a lot of adoption is places where people they're either processing a lot of data. There's diffusion model training companies that use Moondream to synthetically caption hundreds of millions of images to train their models. Or in places where
that to me, that use case makes a lot of sense, because, I don't need to send it over the cloud to an inference provider that's got a really powerful model, and I'm doing a narrow use case. So I need the 500 million will work, and I can run it locally super fast and get through all of my data quickly. So I think that's interesting.
Yeah. In terms of commercial usage, we're mostly seeing interest in places where people need air-gapped vision solutions. So it's stuff like workplace safety, manufacturing in a lot of cases is air-gapped. Retail, surprisingly, like the rooms where they stock stuff often don't have good internet connectivity. Home security. I
would have used, so we my last company, we which is still running, we have freezers, which are basically Faraday cages. I mean, they're incredibly air-gapped. It's like we couldn't do anything inside them, but we did have a need for monitoring, both for theft, but for safety.
Yeah.
And also for optimizing. Want to, like, measure, like, how long does it take for a person to get from here to there? And it would be very simple now. I can see this, to build a system where you just kind of collect data and you get this translated into whatever your domain set is, like person arrived or a person exists in frame, and then a script to, like, compute the travel times or whatever. It'd be easy to accomplish some of the scenarios that we thought we would never get to without having a person stand in a freezer with a clipboard for 4 hours and have it be, suboptimal anyways. So it's just, I can see the air-gapped and industrial use cases.
A lot of this would have been possible 5 years ago. It's just been really expensive because you have to hire an ML team and train custom models.
Sure. Yeah. I mean, the first really exciting moments in deep learning were in vision, right? And so I think that's where I got tipped off to, like, now I've been going to the University of Washington Computer Science PhD symposiums every year. And it was probably 2008 or 2009 where, neural nets were being sprinkled into everything, whether it was database, human factors, UI.
Yeah.
I mean, everything was sprinkling in. And so you kind and then you had, of course, everything that happened since then in the benchmarks early on, AlexNet, et cetera. Well, now that we're on the research topic, what are, in the current state of vision models and reasoning and everything there, what is the hard unsolved problems right now?
The one that's top of mind for us is the fact that, like, we're training these models mostly on data source from the internet, and there's heavy bias over there. The two examples I like to give people are reading gauges. Most gauge pictures on the internet are product detail pictures. They're set to 0. So the models learn to tell you what type of gauge it is, range there is, but it can't tell you what it reads. Similar thing with telling the time. Like, most clocks tend to be set to 10:10 because manufacturers think it looks like a smiley. And so,
is this an important case for business customers? Because
clocks, not so much.
But it's an
gauges, absolutely. And they're kind of related problems. Industrial, right? Like in a lot of oil and gas, for example, you have a bunch of facilities that are remote. You ideally like to not have to send humans to read those gauges. And
Yep. Where are you on visual recognition of like computer interfaces and mobile interfaces and web pages?
It's something we've recently started working on. We do fairly well on like smaller sized images. So like if on your mobile screen or if you downsize your browser a little bit, that's one of the main reasons we introduced the pointing feature. Maybe I can show a quick example if I have a screenshot for UI. I'm not sure this.
We can crop here.
Yeah, I need. Actually, let me just take a screenshot of this. So yeah, in the pointing feature, the image is a little small over here, but you can see thumbs up button, and it detected these.
Can you zoom in?
Yeah, absolutely. So yeah, we're...
Oh, sorry. We're looking at a screenshot of the UI.
Yeah.
And it has circled the thumbs up from the UI of the sandbox. Cool. Wow, that's great.
Yeah.
Pretty tight.
So we're pretty decent at detecting buttons. What we don't have is like some sort of driver that says like, hey, based on this screen and the task the user is trying to perform, here's what I need to do. We've seen people like Open Interpreter, for example, pair it with like a reasoning LLM. So Moondream is a vision component, and then CodeStrill, for example, might be like, okay, I need to click this one.
Sure. Yeah, that's interesting. I mean, there's so much like test automation and automation that you could do with something like an approach like this. And again, like being able to run it locally and make it be efficient and fast and repeatable is probably really useful.
Yeah.
I mean, for all the goodness of the frontier models, they change a lot. And you know, that could throw off something where you're trying to get precision. So I can kind of see why I'm personally very interested in UI automation things.
Yeah, the change aspect is something a lot of customers bring up with us. Like once you have a product that's shipped and working, you kind of don't want to touch it because so your provider decided to upgrade and now your prompts have to change.
And models, the hosted models change a lot. I'd like something frozen and reliable. And especially if we're talking about devices in an air-gapped environment, I can't patch them very easily, right? I need it to be like check past my thing and deploy and sleep well at night. So I see your use cases in those scenarios really strongly. Talk about gaze detection. We haven't shown that one. Do you want to show what that is?
Yeah.
Super cool.
I've got it up here. This was a feature we mostly threw in because we thought it was going to be fun.
Look at that.
And it makes for great demo videos.
Can you combine this with VQA and say like, what is the person looking at?
Yes. So we have a feature in VQA where you can give it a point that you're interested in. So you can point at the person's face in your prompt and say, where is this person looking at? And give you a textual description.
Of what they're looking at.
Yeah.
Oh, that's super cool.
I think there's applications in. So we did it just because we thought it was fun. But it blew up and people were telling us about all sorts of useful things.
What are the use cases that you see?
Sports.
Like what?
Sports tracking. Like build like UIs.
For coaching.
Monitor play
maybe.
Coaching.
Yeah. I mean, keep your eye on the ball, right?
Yeah. Here's an example. When you're climbing, like we can monitor what you're looking at or what holes you're interested in.
I can see coaching feedback, physical therapy, scoring and yeah, interesting.
Detecting cheating during exams. Like I'm looking at the paper.
Looking at somebody's cards in poker.
Yeah. Poker was one of the things we included in our demo video for this.
Cool.
I'm very interested in home automation with this. And things that's super annoying is like, Alexa, can you turn off the living room light number 2? Like instead, if you could just look at it.
Yeah.
Be like, turn that off.
The clapper I like the clapper. It's ambient. I don't have to talk. But it's so lame. And I think I would rather be like, if I look at my lights long enough, they just turn on.
Yeah.
Just like, and have it be an ambient agent that's looking at my security footage and running a thing in Moondream, and it triggers the behavior I'd want at the moment. When I did not want more, who wants more glowing LCD screens in their house with device driver updates and pop-ups and alerts? And, I don't want any of that stuff. And I think I like the idea of a bespoke technology like this in a very focused way running in the background and waking up when I need to. And I cannot run a a video stream to the cloud 24/7 and I can't run inference 24/7, even then it would add up. The cost would add up.
Mm-hmm.
Even the cheap models would add up. And so running something on I guess I need to look at the electricity cost. What is the electricity cost? Whoa, hold on a second.
A motion sensor, maybe? I don't know.
Motion sensor. So speaking of, you know, I don't want to run a stream to the cloud of all video all day long from 6 cameras and inference in the cloud. It would just add up, you know, but if I was running it locally on a Raspberry Pi, what would the electricity power consumption be?
That's not something we measured, so I'm not going to throw a number out.
Yeah. Okay.
But in general, I've seen a number that's like, let me just not speculate and misinform people. Power usage scales linearly with parameter count for the most part. It's really a proxy for flops, and most models in this, compare this to a 7B or a 20B model running in the cloud, it'll be about 10 times less energy usage.
Makes sense. Can you show us the API so that people have an idea of, you've got those 4 modes or 5 with the gazing?
Of course.
Yeah.
So there's a couple of different ways to use it. It's in Hugging Face transformers. I'm going to zoom in a bit. Super easy to get set up if you're already using transformers. You set the model up. You want to caption, you just do model.caption.
Cool.
Streaming is super simple too. We've made this simpler than your typical transformers model. So it just yields a set of tokens. You don't have to deal with a tokenizer or threads and whatnot.
Cool.
If you want to ask a prompt, you can pass that into our query endpoint. If you want to detect an object, you call .detect.
And it looks like you could actually call it multiple times for one image.
Correct. Do we have an example? So there's another method here called encode image. This is where you pre-process the image upfront. It runs it through all of the transformer components it needs to run through and stores them. It takes about 60 megabytes of RAM to, no, not 60, around 30-ish megabytes of RAM to store that. And then you can pass in the encoded image where you pass in a regular image and it won't pre-process it.
So it's pointer to your thing that you've already encoded, and then
you
can run all the different inference modes, the VQA, the captioning, the pointing, all
gaze detection
over and over, and it's fast at that point.
Exactly.
It this way.
Now, so this was the Transformers version. We also have a Python and Node.js client that lets you run it locally. We get this faster inferences on our Python client.
Cool.
We also have an API, like I mentioned. If you don't want to deal with figuring out local inference before you can see if this even works for your app, you can just use it. We give you a bunch of free requests. If you need more, let us know.
Yep.
If you're using OpenAI, by the way, it's 3 lines of code that you have to change to just try it out and see if Moondream fits your needs.
Cool. Compatibility. That's great.
This was one of the things we learned at the AI Tinkerers hackathon, actually, where we were telling, hey, you can run it locally and whatnot. A lot of people are like, why don't you just give me an API? I don't want to mess around with this local inference stuff. Just make it easy for me.
Yeah. I think that's right. For application developers, we're used to putting in API calls and it's simple. That's great. It was good. What else did you learn at the hackathon? What was the value you got out of that?
Honestly, when we came in, we're we're pretty busy, so we're just gonna camp out in a corner and work on our stuff and see how it goes and answer questions if people have them. It was surprising to see how many people went and built with Moondream. I think something like 8 out of 10 teams or something were doing Moondream. That was very energizing for us. Yeah.
What were some of the cool projects that we saw?
Moon Paint was cool. There was this team that was taking pictures from Google Street View.
Yeah, that was so cool.
See, hey, is the paint messed up?
Yeah,
so that they could send you a personalized card.
Maybe we should call them and knock on the door and put a flyer there. Yeah.
That was cool.
Yeah.
That was the one that really stood out for us, is also the need for being able to fine-tune the model.
Yes.
There was a team that struggled then, but will not struggle now because we've since made some improvements, trying to detect wildfires. So there's a grid that you use to assess how the state of the brush.
Yeah.
And they tried to use every model out there, but no one was really good at taking that grid and being hey, this other picture, is that an 8 or a 7 or a 9?
So if the technology has gotten better to solve that use case, the need to solve it has also gone up with LA fires.
Yep.
So that's an interesting,
very top of mind for people.
We should probably do another hackathon. We are doing another hackathon.
We will.
That's really, really cool. What about robotics? You haven't mentioned any like robotics use cases used in actual robots or home devices.
Robotics is something we're just starting to explore.
Mhm.
I think for most people in robotics, like 2 billion is a really big size. You need the robot to respond a lot faster. So with our pruning, that's something we're going to start exploring very soon. We did have a project, I forget the exact name, but they were basically taking existing vision models and training a robotics action head on top of them. And they did, they supported a bunch of models, but I suspect there's a bit of a gap there where nobody's really optimizing the vision model for the final task.
Did you see Maxwell's drone project by chance?
I don't think so.
I published a one-shot video about it, but he's got a Jetson Nano running on a large drone to do some local vision stuff, and then he does streaming to the cloud with an efficient protocol to do some heavier, reasoning and tracking and device command stuff. But it's interesting to see. Here's a guy who's like, he works at SpaceX. He's a few years out of school, young guy, and he's cobbling together very intelligent, advanced systems using these kinds of components. I feel like, right, there's two things happening, stuff like that and slop, and I'm kind of excited about this stuff where ordinary people, ordinary, amazing engineers can build incredible things that were kind of felt like moonshot ideas a few years ago with things like Moondream. What would you say to someone who wants to train their own models? Like, you've done that. Were you doing that before? Let's give a little bit about your background in ML and how did you come to this?
I studied machine learning in college, maybe 10, 12, I forget when. But it was back before we were doing deep learning. So it sucked. We were using MATLAB, doing speech recognition stuff with handcrafted features. So I was like, I need to get out of this field as soon as possible. So I joined Amazon, worked at AWS for like 8 years. I think Stable Diffusion coming out was like the pivotal moment for me. I was like, wait, what am I doing?
Interesting.
So that weekend I went out, bought a 3090 from someone on Facebook Marketplace and started tinkering. Coming out to AI Tinkers meetups.
That was the moment, actually, so people forget, but before LLMs were open sourced, right?
Yeah.
Stable Diffusion was the first thing that gave me hope that there would even be an open source large AI thing at all.
It was visual. People love creating images and you could fine tune it. A great way to get into it. So that's how I got started. Watched a bunch of videos about diffusion models, Karpathy's, neural networks, here to hero. Tried to move internally at
So
Amazon.
You trained ML in school in the theoretical classroom sense at Amazon. Were you doing
No,
nothing?
Distributed systems.
Engineering, laying bricks.
Yep.
Okay. And then you got inspired when Stable Diffusion came out. It's not that many years ago. 3.
Something like
that. And then just started learning. How did you learn? What were the resources? Karpathy.
Jonathan Whitaker has a really great series. I think his YouTube channel is called Datacastnet, something like that. Amazing course on diffusion models. Goes super deep into how a U-net works. Nice. That was the primary source.
Oh, cool. We should tag these people when we publish this.
Yeah. Mostly that. And honestly, I think one mistake a lot of people make here is like trying to read too much. Too many papers, too many videos. Yeah, just do it. Go fine tune a model, try to build something, see where it breaks.
Yeah. This is the same advice for use of frameworks.
Yeah.
Just do it. Just build it. What is your opinion on, let's talk about your tinkering. You're not only doing this stuff, you're using this stuff, but I'm sure you're tinkering like we all are with all kinds of stuff. Tell us more.
What's top of mind for me right now is coding agents.
Yeah.
I think I tried out Open Hands recently and I was kind of stunned by how good it was. Obviously a lot of sharp edges, but it's definitely to the point where you can see the potential. Like it's like having an intern on call 24/7.
Interesting. Have you tried Bolt or Windsurf, or I assume you use Cursor? Or
I don't use Cursor. No. I'm a Z user.
What's that? What?
ZED. It's
Is that like Vim or something?
No, it's I forget. I think this might have been the guys who made Atom or something.
Okay.
Who started
I'm embarrassed to not know it. I just destroyed my own crud right now.
So I tried out Cursor. I found that for the types of work that I was doing, which is writing a lot of PyTorch code, the LLMs aren't very good at it right now.
Yeah.
Secondly, like when they screw up, like when you screw up most code, you can tell that something is broken. When you're training models or writing inference code, everything looks like it's working and your accuracy is just short. So I've been avoiding using LLMs a ton for most of my.
You mean because it might produce something that runs and wastes a lot of time before you understand that it was wrong?
Yeah.
I can see that.
On the flip side, there's tasks that I do, like a lot of data set processing, copy this from here to here, etc., that they're able to do fully autonomously. Like I don't need to be in the loop for that. And so that's where projects like Open Hands are interesting, because you just give it a task, it goes off. Sometimes it takes a lot of time to figure it out, but I don't mind. I can work on other things while it's doing it.
What have you built like for fun?
Honestly, Moondream takes all my time. So gaze detection was a fun project.
Are you automating anything like your inbox or social media or monitoring or competitive or research?
We are automating the feedback mechanism over here. So when you click thumbs up, thumbs down over here, we have this running, not very well, but I know how to fix it. Like an LLM looks at what image this is, tries to like look at patterns and then tell us like, hey, you need to improve this specific capability of the model and go find some training data for that. Yeah, cool. But I think we can go further and have the LLM also like generate that data set, add it to our fine tuning. And
cool. You were the first company, it was before it was really a company, but like who was doing the AI Tinkerers like world tour.
Yeah.
So I was like, oh, Vic this is great. You know, I didn't know you that well personally at the time, but we obviously interacted a few times, and you've been in Seattle meetup a bunch of times that I'd seen you, but then you were in Palo Alto and you were in different cities. And tell me about how you first discovered AI Tinkerers and what your experience with that was.
First found out about it on, I forget, meetup.com or something. I was honestly very nervous to show up. I was like, I'm going to go, there's going to be all these smart people. I'd be an idiot there. But it's super welcoming community. Everyone's amazing.
Yeah.
So I came out to one in Seattle, maybe November of 2023. It was amazing. Around the time I quit my job, so I was trying to figure out what's next. So it was just like, look, meet people. Do I move out of Seattle? Do I start a company? Do I get a job? So I just looked up like, hey, where's AI Tinkerers happening outside of Seattle?
Yeah, cool.
Would fly there, meet people. It was great.
I've heard people say AI Tinkers was able to keep me in Seattle because I feel like there's a community. That makes me feel really good. Although now you've gone to the Bay Area with AI Tinkerers, and has that been valuable?
Absolutely. There's a lot of people building in a lot of startups. And when you're a startup, you want to sell to startups.
Yeah. What's the status of the company? I know, you have a co-founder, you have employees, you've got funding. Like tell people about where you are and what your needs are.
Yeah, we did a raise earlier this summer, fall. There's 7 of us now, all in all.
Who's in your round? Who was your seed round?
We only did a pre-seed so far. We had Felicis, Microsoft, and Ascend.
Yeah, Kirby.
Yeah.
Ascend.
Yeah.
Great.
Ascend was in CrowdCow as well.
Right? Yeah. I've known Kirby for a long time, and he's invested in 2 companies of mine.
Ascend is amazing. Like if you're in Seattle, and you want them on your side.
Yes. I always counsel people, you want former operators who have founder empathy, and that's pretty much the main criteria. It's non-negotiable, and Kirby's got that in spades. I'm glad to hear that that's working out for you. What else do you want people to know about Moondream? Where can they go? Moondream.ai to get started.
Yep.
And what would you like to see them build? And just what else would you like people to know before we wrap up?
Go to Moondream.ai. It's state-of-the-art vision model running on your computer for free. Try it out, build stuff with it. We're very active on our Discord, so would love to see what people do with it. If it doesn't work for you, that's amazing feedback for us.
Awesome. We'll put the Discord in the notes on the show notes. And thanks for coming on, Vic. This is awesome.
Thank you for having me.
Thank you.